Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 26, volume and surface area. So the opening exercise is a classwork, and if students were in groups, they would explain to each other, try to determine how they would find the area of the shaded region, and then calculate it. So hopefully you can try this on your own. Pause the video, see if you can do it, and I'm going to come back and find the area of the shaded region. Okay, so here we go. First thing I do is write the formula, and the area of the shaded region equals, it's S-H-A-D, area of the shaded region equals area of the large rectangle minus area of the small rectangle. So the small rectangle is here, and the large rectangle is the outside dimension. So it's like a picture frame. Okay, so there are the two regions, and if we take the larger and subtract the smaller, we will get the area into, and that's our goal here. Okay, so the area of the shaded region equals length times width minus length times width, the area of a rectangle. Okay, area of the shaded region equals the length of the red is 6 centimeters. The length is 3 centimeters. And we're going to subtract the length of the smaller rectangle times the width of the smaller rectangle. So the area of the shaded region equals 6 times 3 is 18 centimeters squared minus 5 times 2 is 10 centimeters squared. So therefore the area of the shaded region equals 18 minus 10, or 8 squared centimeters. Okay, here's example 1. It says volume of a shell. The insulated box shown is made from a large cube with a hollow inside at its right rectangular prism with a square base. Okay, so there's the key. There's a keyword right there. A square base. So if this is 18, this is 18. The squares have same sides. The figure on the right is what the box looks like from above. This is an aerial view. This is a view from the side. Calculate the volume of the outer box. So the first thing we always do is write a formula. So volume equals length times width times height. So volume equals, the outer box is also square. So if that's 20, if the side's 24, the front's 24. So the length is 24 centimeters times the width, which is 24 centimeters, times the height, which is 21 1/4 centimeters. Okay. Okay, these are fairly large numbers, so I'm going to save time by using a calculator. So it's 24 times 24 times 21 1/4 is 0.25. So 24 times 24 times 21.25, and hit enter. So the volume equals 12240 centimeters cubed. Okay. Okay. I misread. This 21 1/4 is not labeled very well. That's 21 1/4. This is a cube. So this is also 24. So I'm just going to make one minor change here. And I'm going to change the last 21 1/4 to 20. That's times 24 centimeters. So this is 24, 24, and this is also 24 cm here. 21 1/4 is the height of the inside. Alright, so now when I calculate that, that's 24 times 24 times 24, which is 24 to the third power. So 24 to the third power is 13,824. 13,824 cubic centimeters. Okay? Now B says to calculate the volume of the inner prism. So the volume of the inner prism is 18 by 18 by 21. So volume equals length times width times height. So volume equals 18 times 18 times 21 1/4. So the volume equals, and I should have centimeter, 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 but I'll just add it at the end. 18 times 18 times 21 1/4. So 18 times 18 times 21.25 equals 6,885 cubic centimeters. So I found the volume of the outer box, I found the volume of the inner prism, and then the next thing is going to say, describe in words how would you define the volume of the insulation. Volume of the insulation equals volume of the outer minus the volume of the inner. So calculate the volume of the insulation in cubic centimeters. Well, there's a misprint. Describe in words how you'd find the volume of the insulation. So I'm not really liking this problem very much because the insulation would be around here. I don't know if you would put insulation in the middle of something and something all the way around the outside. That makes no sense. So I think what they're trying to say is find the volume of the area inside. The insulation is this gray area. No, I guess that is right. The volume of the gray area is the insulation. So it's going to be the area, or the volume of the insulation is the volume of the whole box minus the volume of the inner space. So it's going to be 13,824 minus 6,885. Okay, so the volume of the insulation equals volume of the outside minus volume of the inside. Okay, so the volume of the insulation is going to equal, love when it goes to the next page, 13,824 minus 6,885. Yes, minus 6,885 centimeters. So the volume of the insulation equals 13,824 minus 6,885, 693. Per cube volume. So the volume is 6,939 cubic centimeters. Now it says to calculate the amount of water in the box can hold in liters. Okay. All right, I knew there was an error somewhere. They asked us to find the volume of the insulation. And then now they're saying calculate the amount of water the box can hold in liters. So if I go back and look at this thing, well, where's the water going to go? The water's going to go in this space in here, the inner prism. The inner prism is hollow. The water's going to go in there. The insulation is here. The water goes inside the insulation. So we've already calculated the volume of the inner, which is 6,885 cubic centimeters. Okay, so the volume equals 6,885 centimeters cubed. It says calculate the amount of water the box can hold in liters, not cubic centimeters. So a liter, so what we're going to do here is take 6,885 centimeters cubed. That is going to equal 6,885 milliliters. Okay, a cubic centimeter is a milliliter. Well, milliliter is 1,000 liters. So that is going to equal 6,885 milliliters divided by 1,000 milliliters per liter. And that is going to equal, and all this is going to do is move the decimal 1, 2, 3 places to the right, 6.885 liters. So milliliters we cancel. 6.885 liters. Okay, so now we have exercise 1. You have been asked by your school to design a brick planter that will be used by classes to plant flowers. The planter will be built in the shape of a right rectangular prism with no bottom, so the water and roots can access the ground beneath. The exterior dimensions are 12 by 9 by 2.5 feet. The bricks used to construct the planter are 6 inches long by 3.5 inches wide, and they're 2 inches high. A says, what are the interior dimensions of the planter if the thickness of the planter walls is equal to the length of the bricks? Okay, so what we really need to do is draw a picture here. It's always a good idea to draw a diagram and label it to see what's going on. So let me bring in a diagram. I'll be right back. Okay, so here's a diagram of that. So 12 feet, 12 feet, 9 feet, 2.5 feet high. The bricks are 6 inches long, 3.5 inches wide, 2 inches high. Okay. So it says, what are the interior dimensions? So I want to know this interior dimension. Well, if it's 12 feet from on the outside dimension, and this is 6 inches, we need to subtract 6 inches from here and 6 inches from here, totaling a foot. So that'll drop us down to 11 feet. Okay, so the inside length is going to be, first thing we want to do is 6 inches is a half a foot. All right, so now we're down to the interior length of 11 inches. So I'll just label it here if we get a better color. Yellow will work in here. There we go. So from here, now we're down to 11 feet inside because we subtracted 6 inches from this piece and this piece, totaling 1 foot. We're going to do the same this way. So if this is 6 inches, this is 6 inches, we're subtracting a foot from 9. So the inside dimension from here to here is now going to be 8 feet. So the area, I better change colors now. So the area of the interior equals length times width. Area of the interior equals 11 feet times 8 feet. So the area of the interior is 88 feet square. Okay. This says what are the interior dimensions of the planter? So actually I answered the question right. Okay. I did not ask for this, but that's okay. Now it says what is the volume of the bricks that form the planter? So I need to find the volume of the interior, the volume of the exterior, and subtract. Okay. So the volume of the bricks equals volume of, let's see, the larger prism, the volume of the large minus volume of the small. So the volume of the bricks equals volume of the larger is length times width times height, and we're going to subtract the volume of the smaller, which is also length times width times height. So 12 by 9 by 2.5. So the volume of the bricks equals 12 feet times 9 feet times 2 1/2 feet. We're going to subtract length times width times height of the interior, which is 8 feet times 11 feet times 2 1/2 feet. So the volume of the bricks equals times 9 times 2.5, 270 cubic feet. Larger, and now we're going to subtract 8 times 11 times 2 1/2. So 8 times 11 times 2 1/2, and that is 220 cubic feet. Okay, so finally, the volume of the bricks equals 270 minus 220, or 50 cubic feet. Okay, part C says if you're going to fill the planter 3/4 full of soil, how much soil would you need to purchase, and what will be the height of the soil? Okay. So we're filling it 3/4 full of soil, and the height was 2 1/2 feet. So 3/4 times 2 1/2 is the first thing we need to calculate, which is the same as saying 3/4 times 5/2, which equals 15 over 8. 15/8 of a foot. That's going to be the height of the soil. So the volume of the soil in the planter is going to equal the interior, which was 11 feet, times 8 feet, which was the width of the interior. 11 feet times 8 feet times the new height, which is 15/8 of a foot. So the volume of the soil is going to be 11 times 8 times 15/8. Well, 8 times 15/8, the 8s will cancel. So we're just doing 11 times 15. 15 times 10 is 150, plus another 15 is 165 feet cubed. Okay? Now D says, how many bricks are needed to construct a planter? So we need perimeter for starters. So we need to look back at that diagram again. So the perimeter of this is 8 1/2 feet. And the way we're going to calculate this, let me switch to a darker color. Actually, let me get rid of this, all this writing, and I'll use yellow. So looks good. All right. So if I'm going to break this up, and I'm going to choose an area here, and I'm going to stop here, and then I'm going to choose this here, I need to stop, because I don't want to count the corners twice, so we're going to get overlapping sections. So the first thing you need to be able to identify is that we can't count corners twice. So this is going to start at this edge, but it's going to stop at this interior edge, because this is going to start at the exterior edge and go to this interior edge. So you see how the greens and the yellows are offset, so that every portion is covered, but there's no overlap. So when I do that, I'm cutting off a 1/2 foot of length. So now my length is 8 1/2 feet by 6 inches. Okay, so now let's calculate. So the perimeter is 2 times 8 1/2 feet, because there's two sides that are equal, the opposite sides, plus 2 times the new 12 feet minus a 1/2 foot, which is 11 1/2 feet. So the perimeter equals 17 feet plus 11 1/2 times 2 is 23 feet, which equals 40 feet. So there's the perimeter. And then 3 1/2 inches we're talking about the brick's width. Okay. Brick is 3.5 inches wide. So if we stack these bricks up side by side, let me bring in a diagram to explain what I'm doing. Okay, so here's my diagram. See how they offset. So if we have these sections here all the way around, and each brick is 3.5 inches thick, then how many bricks do I need to fill these in is what I'm trying to figure out. So what I'm going to do is, first of all, 3.5 inches, I have to convert to feet. So 3.5 inches. 3.5 inches is going to equal how much of a foot? Well, what do we divide by to get an inch is a 12th of a foot. So it's going to be 3.5 times 12. That's 42. Oh, we're not multiplying. We're taking 12 inches divided by 3.5. And we get a fraction of 24. 7 over 24 is how I'm going to do it. 7/24. So it's 3.5 divided by 12. I did it backwards. So we're going to take 3.5 inches divided by 12, because there's 12 inches in a foot, to get how many feet there are in those 3.5 inches. And that's 7/24 of a foot. Okay, so 3.5 inches is 7/24 feet. I guess I could have just said 7 halves and multiplied it by 12, 7 over 24. Okay, then we divide the perimeter by the width of each brick in order to determine the number of bricks needed. So the perimeter is 40. The perimeter is 17 feet plus 23 feet. Okay, so hang on one second. Okay, so here's our perimeter. Perimeter was 40 feet. So we're going to take that 40 feet and we're going to divide it by 7/24, which is going to equal 7 times 40 is 280 divided by 24. And let me just see, let's use a calculator. 40 divided by 7 over 24. Okay, so that's going to equal 960 over 7. Okay, oh, I see what's happening. I know what I did now. All right. It's division. So I cannot divide a number by a fraction, so I have to multiply by its reciprocal, and that's going to give me 40 times 24, which is this 960, and that came out to be 137.1 bricks. Okay, obviously this is not including the mortar that goes in between the grout. Okay, now part E says, each brick used in this project costs 82 cents and weighs 4.5 pounds. The supply company charges a delivery fee of $15 per whole ton, which is 2,000 pounds, over 4,000 pounds. How much will your school pay for the bricks, including delivery, to construct the plant? So the school has to purchase, let's see, how many planters are they going to make? Okay, I haven't finished the problem yet because all I did, how many bricks are needed to construct the planter? There are 137.1 bricks per layer. Okay, so the height of the planter is 2.5 feet. Let's see, what's the height of the planter? Bricks to construct the planter 6 inches long, 3.5 inches wide, 2 inches high. The planter is 2.5 feet high. Okay, that's where we're going on. That's what it makes it difficult to do a problem like this when it's on several different pages. Okay, so the planter is 2.5 feet high. So we just do a layer. It's going to take 137.1 bricks. Okay, 2 inches equals 1/6 of a foot. The height of the planter is 2.5 feet, which is equal to the product of the number of layers of bricks and the height of each brick, which is 1/6 of a foot. So what I need to do is take 2.5 feet, the height of the planter, and make that equal to 1/6 length of the brick. So we're doing 2.5 feet equals 1/6 L. I need to find the L. So in order to solve for this now, I have to multiply both sides by 6. Okay, so the 6 over 1 and the 1/6 is going to cancel, leaving me with L equals, on the other side I have 5/2 times 6. 6 over 1 times 5 over 2, which is 30 over 2, which equals 15. So that's how many layers they are. I said length back here, I meant layers. Okay, so a layer is 2.5 feet thick, and 1/6 of a foot is 1 brick. So I need 15 bricks or layers to generate this, to have enough bricks for this planter. So now the total number of bricks B will be equal to the product of the bricks in each layer and the number of layers. So bricks is going to equal layers times number of bricks per layer, which is 960 over 7, which is going to equal 960 times 15. Which is 14,400 divided by 7. Finally, if I just hit divide 7, we get 2057.1 approximately. So we need 2,058 bricks. Okay, we're not going to round down. We need all the bricks we can get. So 2,058 is going to be our key number. So now they're 82 cents each. So now I have to set up an equation. If the school purchased 2,058 bricks, the total weight of the bricks for the planter. Okay, now each brick weighs 4.5 pounds. So the first thing I need to do is take 2,058 times 4.5 pounds, which equals 9,261 pounds. The number of whole tons over 4,000 pounds, because anything over 4,000 pounds, they're going to charge $15 per ton. So I have to take this 9,261 pounds and subtract 4,000. That's how much they ship for free, and it's going to be 5,261 pounds that we have to pay for. So since 1 ton is 2,000 pounds, there are 2 whole tons of 4,000 pounds. Okay, 2 whole tons is 4,000 pounds, and 5,261 pounds. Total cost of bricks plus cost of delivery. So cost of bricks plus cost of delivery equals the total cost. So here's my equation. So the total cost is going to equal cost of the bricks, which was 0.82 cents, times the 2,058 bricks that we need, plus, and we need 2 tons of bricks, so it charges $15 per whole ton, 2,000 pounds over 4,000. We were 5,261 pounds over. And 1 ton is 2,000 pounds. There are 2 whole tons of 4,000 pounds. 5,000 pounds. Since 1 ton equals 2,000 pounds, there are 2 whole tons and 5,261 pounds. So 3 tons would be too many. So we're only going to go with the 2 tons times $15. So when we calculate this, I already have it figured out here. 82 cents times 2058 is $1,687.56 plus the $30 for delivery. So my total cost is going to be $1,717.56. Okay. I'm going to stop the video here, and I'll start a new one on the next example, and I will name the videos part 1 and part 2.